Hey, fifth graders. This is weird. So I'm going to be doing a little lesson about the first page in your homework packet right now. I really wish we were sitting in my classroom. Instead, what we're doing is we're sitting in my dining room. So you see my fun little built-in shelf behind me, and this right here is my fairy godson, Asher. Isn't he adorable? Anyways, so this is our classroom for today. I hope you are doing well and that you're staying inside, or at least staying 6 feet away from people and not playing with your friends right now, even though that's super hard. But the more we all follow the directions, the sooner this will all be over and we can go back to life that's more normal, because this is weird. Anyways, we're going to try this out. So welcome to the math show with Miss Condry. Woo! Round of applause. I know you're all doing it. Actually, you're probably all rolling your eyes at me right now. That's okay. Because I can't see you, so. All right. We need to set up some norms here for our classroom today. So I've got some norms and some things that I want us to think about as you're doing math at home, and maybe even with the help of your parents. First of all, I want you to remember to have a positive attitude. This is hard for all of us. It's hard for your parents. It's hard for me because I'm not sitting right next to you and I can't tell what you're thinking. It's very strange to teach a lesson to a camera. So let's make sure we're all having a positive attitude. Please be respectful. I know that your parents might have different ideas than you about how to approach solving a problem, but it's really important that you're respectful during this time. They're doing the best they can, and you need to do the best you can also. And then also, let's make sure to keep trying, even when it's hard. Some of these pages it might be hard to do at home because you forget the strategies that we've talked about in class. We've learned a lot this year and we've covered so much information. But keep trying even when it's hard. And I'm going to try and approach some of those, some of the things that I want to remind you about in these videos. And then also remember the word try. That's a really powerful word. Not try. The word is yet. Really remember that word yet, because as you're working through these things, it might be really frustrating, or it might take you a long time, and you might be tempted to say, I can't do this, or I don't know how to do this, or this is too hard. But instead, what you can say is, I don't know how to do this yet, or I'm not very fast at this yet, or this doesn't make sense yet. Remember, it's all of us are on our own different learning curves right now, and we're just going to try the best that we can. All right, so I'm going to go over the first page in your learning packet in this video. It's page 113. So I wanted to talk a little bit about what you're going to be doing in this page. You might have already looked over it. There are 2 standards. I told your parents I would post the standards because it's helpful for them to know what you're trying to learn. So these are the Common Core standards. These are your learning targets in this page. It's all review. Even if you can't remember it, I promise we've done lots of this stuff this year. Okay, so the first one is that we're going to try and understand addition and subtraction of fractions. Okay, I didn't say we're just going to be a bunch of robots who can get the answer, right? I said we're going to work on understanding. So we're going to use some visual models. And then the other thing that you're going to review in this page is reading and writing and rounding, turns out, decimals to the thousandths place. And that includes reading it right at home. Even if your parents are allowed to say point, which they are, you need to read it the correct way because that is going to help you understand the math that you're working on. All right, so I want to talk about the very first section of page 113. There's a few review problems that are all having to do with adding and subtracting fractions, and you'll notice that the fractions have different denominators. And this is a review from a couple units ago. We've moved into multiplying and dividing fractions in the last couple weeks before all of this hit. And so I want to remind you of a really common mistake that kids make and actually even adults make. I've seen adults make this several times. And it's easy to do because we want to think about fractions as regular numbers. And fractions are not regular numbers. We know that they're made up of a numerator and a denominator. The numerator's on the top, the denominator's on the bottom. And those numbers have a very specific meaning. So let me show you. I want to find a little page to cover this up. I'm going to show you a really common mistake that you might be tempted to do when adding and subtracting fractions. So the very first problem on the page is 1/3 plus 3/8. A lot of people are going to just want to add the numerators, 1 plus 3, which equals 4, and add the denominators, 3 plus 8 equals 11. Really smart mistake, but it's a mistake. And the mistake is that this person who did this doesn't understand what the fraction means. So I'd like to go over that. This is why it doesn't work. Like I said before, the fractions are made up of two parts, the numerator and the denominator, and those numbers have a very specific meaning. The denominator, the bottom number, that 4 there in this example, so I just used 3/4 as a random example, it has nothing to do with the page. But 4 means that in a whole, there are 4 equal pieces. So if you think about a brownie, it means that I've cut the brownie into 4 equal parts. The numerator is the number of parts that we're talking about. So if there's 4 equal parts, we're talking about 3 of them. Okay? So that's the meaning of this. And if that's the meaning of the fractions, then I gave a little visual example of why this common mistake doesn't work. So here we go. We have proved this. You guys actually did a lot of this work at the very beginning of the school year, and we really unpacked these ideas. You also did a lot of this last year in 4th grade. Okay, so if I know that 1/3, if I know that the 3, the denominator, means how many equal parts in the whole, here's my brownie. I cut it into 3 equal parts, and since the numerator is 1, I colored in 1 of them. For 3/8, similarly, the denominator 8 means 8 equal parts in the whole, so I made 8 semi-equal parts, okay, and colored in 3 of them. And then if I make the answer that I got from up here for 11ths, you'll see I tried to cut that brownie into 11 equal parts. That was kind of tricky, and I colored in 4 of them. And I can tell right away that if I were to add 1/3 and this 3/8, that it would be quite a bit bigger than this 4/11ths. So it doesn't make sense to add it that way. That can't be equal. So instead we need to think about something different. Okay. Parents, if you're watching this with your kids, what I would recommend doing is if any part of this first introduction seemed confusing, pause and go back and think about it, and maybe even now ask your child to explain in their own words why it doesn't work to add the 1/3 plus 3/8, just the numerators and the denominators, and have a little conversation about that. Feel free to pause the video and then join me again. We'll talk about some strategies that we can use. All right, so now what we need to remember to do when we're adding and subtracting fractions, and this is some review, is we need to remember to find common denominators. This is so important. Basically what this means is that we need to remember to make the pieces the same size. So if we're talking about thirds and adding thirds with eighths, those pieces are very different sizes. Thirds are quite a bit bigger pieces than eighths. So we need to make them all the same so that then we can add and subtract them, and it will make sense. So parents, what your child has been doing since 3rd grade with fractions is really trying to understand what an equivalent fraction is. And they've done a lot of work around this, and they've used a lot of visual models. So I'm going to jump ahead a little bit because we're at the end of 5th grade here, and I'm going to show 2 strategies. One is a visual model that kids have seen in the past. And this is more around 4th grade where they were trying to come up with equivalent fractions, and I'm going to show a visual model for how to do that. And then I'm going to talk a little bit about another strategy called the ratio table that kids have been learning this year to be a little bit more efficient and fluent with finding common denominators. Okay, so finding common denominators. That means we need to change these two fractions into different fractions that mean the same thing. So I'm going to try and do this so that you can see it, because I think it's important to watch how this works. But if I think about that model that I had before, that 1/3 model. So here I'll draw a little brownie again. And I've got my 1/3, or my thirds, and then I'll draw a same size brownie over here for the eighths. Now this is not a super efficient way, but if it's helping you to understand it, then you should use it. So eighths, I always make fourths, and then I cut the fourths in half to make eighths. So the problem is right now you can see that the thirds and the eighths are different size pieces. So we can't just add them and expect to get a reasonable answer. So I'm going to shade in 1/3. And the idea is that we're going to change these fractions so that they're the same size pieces. And then we can see how to make them into a new fraction with the same denominator. So one thing I know about thirds and eighths is that they both can create 24 equal pieces. I know that because 3 times 8 is 24. Yeah, so this is going to be a fun little challenge to try and create 24 equal pieces here. Okay, so I'm going to start, let's see, 3. I probably should have done it a little bit differently, but that's okay. So we've got 8 pieces here. Four, 8, 12. Yep, that'll work. Okay, I'm gonna just cut them apart like this. All right. And now we can see there's 24 pieces here. And then I'm going to do I think that's 24 there too. 1, 2, 3, 4, 5, 6 by 4. That's 24 pieces. Okay, so each of these now has 24 pieces in it. So that's our new denominator. And our new numerator is going to be how many pieces are shaded in. So in the 1/3 piece, since I multiplied this whole thing by 8, now there's 8 times as many pieces. There's also 8 times as many pieces as I had shaded in. Before I had 1 shaded in, now I have, you can count them, 1, 2, 3, 4, 5, 6, 7, 8. 8 24ths. And then over here we had 3/8, and now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 24ths. So I think that's right. Yeah, that's good. Okay, so now what we can do is we can just add it. If we were to put those together, and if I were to combine these parts, I would have a total of 17 little pink sections, and the whole would still have 24 equal parts in it. So the answer for that one is 17 24ths. Now, this was a little cumbersome and not the most efficient. It's a really great model for understanding why it works. It's not the greatest model for using if we're going to do a bunch of different problems. So 5th graders have been learning about a strategy called a ratio table. The ratio table is so nice because it basically helps us think about how earlier I made this 8 times as big. I made the thirds 8 times as big. So 8 times as many pieces, and then 8 times this numerator here and 8 times this denominator here, and got me 8 24ths. For the 3/8, I had to do 3 times as many pieces here to make 24 parts, which means I had 3 times as many pieces here to make the 9. All right, so we unpacked a lot of that, and now what we do is our ratio table. So 5th graders, some of the things that I'm saying are for your parents to help them understand also, because they have not been in class with us all year. And now they're expected to teach you. That's super fun for them. Okay, so 1/3 plus 3/8. So I want a common denominator. And I could do a whole bunch of things here. I could make 3/8 if I multiplied it. Well, let's start with the 1/3. I could multiply the numerator and the denominator both by 2. So 3 times 2 is 6, and 1 times 2 is 2. So now I know that 1/3 is equivalent to 2/6. And I could prove that on a visual model like I did before. I'm not going to spend the time doing that right now because we just need to remember it. Likewise, I could do 8 times 2 is 16, and 3 times 2 is 6. And I could make an unlimited number of equivalent fractions. So 6/16 is equivalent to 3/8, and I could keep going forever and ever and ever. I'd rather not do that. I would rather be more efficient. So we already know that 8 and 3 are both factors of the number 24. So I could put this 24 here because I know both 8 and 3 can make 24. If I skip counted by 3s, I'd land on 24. If I skip counted by 8s, I could land on 24. And here I can see that the relationship between the denominator here, it's 8 times. So since 3 times 8 is 24, I have to do the same thing to the numerator if I'm going to keep the fractions equivalent. So we take the 1 and I do times 8, and now I've got 8/24 as the fraction instead of 1/3. And then for 3/8, I know that 8 times 3 equals 24. So 3 times 3 equals 9/24. And now I've changed my 3/8 and 1/3 into fractions that mean the same thing. They are equivalent, but they have the same denominator now. So now it's way easier to add or subtract them. So now I can just do 3/24 plus 9/24. And by 3/24 I mean 8/24. Oops. And that will equal 17/24, and that's my answer. I don't have to do anything else with it. All right, I hope that's super helpful. And I hope that helps you remember. So you've got just a few problems to practice that with, and then you can work on your decimal work. Quick reminder about decimals. Oh, parents, if you want to pause the video right now and just go over some of that stuff with your kid, that's totally fine. I know this video is getting a little bit long. All right, the very last thing that we're going to talk about, and I'm just going to touch this briefly, is decimals. Parents, this visual model is going to look confusing to you, but trust me, we have models in our classroom that we use. We call them our, what do we call them? Base 10 pieces. And they're really great for helping kids understand decimals. But basically, we have these mats that are 10 by 10 grid. So there's 100 pieces in them. And then we have a strip of that mat that looks like this, and it's 1/10 the size. And then we also can break that further into 10 equal parts and have these little parts here. So we're using that to understand the meaning of the places in the decimals. So the 4 here is in the ones place. So that means there's 4 mats. And the 3 here is in the 10ths place. So I've got 3/10 and 5/100. And the reason these are tenths is because 10 of them can fit into a hole. And the reason these are hundredths is because 100 of them can fit into this hole. Hard to show without the actual visuals, but one thing we can also know is that we could also break all of these up into little hundredths size. So we could actually have 35/100ths, which is actually how we read the decimal. Or we could have the 3/10ths and the 5/100ths. We could also break each of these into tenths. And so there'd be 10/10ths, 20/10ths, 100/10ths, or 30/10ths, 40/10ths. So we'd have 40/10ths and actually 43/10ths and 5/100ths. So the work that you're being asked to do at the bottom of the worksheet is to make sense of that. I'm really trying hard to help kids use the correct math terminology for reading decimals. I know in real life we say 4.35, but in math, when we're doing math and trying to make sense of decimals, it's really important that they actually read this 4 and 35 hundredths, and that they label that last place value. So I'll write that up here. I want them to be saying 4, and then instead of point, I want them to be saying and then I want them to read the entire number after the decimal. So they would read 35. And then since the 5 lands in the hundredths place, I want them to label it with their words hundredths. I could go on and on about how important it is that they understand those pieces just to make sense of decimals and to really make sure that they understand the place value of the decimals. It's a really pretty important concept in our number system. So if you can help hold your kids accountable to that, that would be great. They don't like doing it. All right, and that has been Math with Miss Condry. If you have questions, you can leave them in the comments, or we're gonna also, I'll be on Zoom tomorrow or Friday at 11, and I'll hopefully be setting up some office hours. So happy math. Bye.